Okay, going back to your page 34 quadrilaterals flip book, we are going to now cover rhombi, and you know how this goes. Same technique. We cover it. I hand you your practice sheet. Instead of throwing a Delta math at you, I'm putting you on just a regular worksheet. And the expectation is to finish the worksheet before you get to class tomorrow. Now, some of you just accumulated a really bad practice grade today. It's not going to kill your grade as long as you don't do it again. Don't make a habit of it. So between now and tomorrow, you need to make sure to finish today's page 37 practice sheet that you're going to get. It's the same format as the ones we've been doing. Probably about 13 questions. And I'm going to help you with a few of them. You have flex today. You have any time tonight at home. And then you have before you get to me tomorrow morning if your first block class is one of those that, for whatever reason, doesn't do anything. So there you go. So don't make excuses, okay? Make improvements so that you're ready for this test on Friday. I want a good test grade out of y'all. All right, so we're flipping to rhombi. And this is out of order. But that's okay, right? Did I copy it out of order? No, I didn't. All right, so this my slides are just out of order. Easy fix. Okay. You know where this is going, or you know where this is starting. A rhombus is a type of, starts with a P, parallelogram. So go back to the concept of a parallelogram. A rhombus is a parallelogram with extra properties. So what do you think the first 5 properties are right here? The exact same as parallelogram. So you can go to your parallelogram page, and then you can flip to your rhombus page, and you can copy those 5 properties down. Copy those 5 properties from the parallelogram to rhombus. And the reason I want you to do it instead of me writing it and you copying my work is because when you're flipping to that page right now, you're actually reading. Studies show that if you read it, you retain it better than if someone just tells you. Studies also show that if you write it after reading it, you also retain it better because you just processed it 2 times. As opposed to if I say, hey, write this word down. There's not as much processing going on.
No, this is
Now, there's a privilege to sitting on the couch, and that is you're still actively participating. I'm just making sure you understand. That's not a, oh, you're copping out and you get to sleep. That's a, I'm still going to do my work. I'm going to prove to her I'm in tune, and I'm taking notes, and I'm listening, and I'm thinking. All right, in a parallelogram, you have opposite sides are parallel. Opposite sides are also congruent. Opposite angles are also congruent. Consecutive angles are supplementary, which means what number? 180. This should be repetitive, y'all. Should be repetitive, and that's so that you'll remember it, okay? And then the diagonals bisect each other. Okay. We have 3 new properties. We are dealing with a rhombus, which looks like a parallelogram that has been compressed, right? Compressed meaning like shrunk horizontally. The easiest way to think of a rhombus is instead of, remember when I said to think of a parallelogram as a rectangle that's been pushed? Okay, think of a rhombus as a square that's been pushed. You with me? So a parallelogram is a rectangle that's pushed. A rhombus is like a square that's tilted, that's pushed. So first of all sides are congruent. Because remember, we're talking about it's like the same concept as a square. Here's the new part. This is the where rhombi are extra. If you want to use it, they're bougie, I guess you could say. The diagonals are what's called perpendicular. That's a very big word. We need to make sure you know what that word means. That word's going to come up a lot. Let's go back to what parallel means. What everyday thing around this world reminds you of parallel lines? Train tracks. They never cross, right? Like a right and a left track of some train track running down the road, they never cross. Okay, perpendicular lines actually cross, and it's always at a 90-degree angle. Perpendicular lines do cross, and they always cross at a 90-degree angle every time. And in fact, there is a notation for perpendicular without having to write the word perpendicular out every single time. There is a notation for it, kind of like the word parallel also has a notation. Let me show you. If you have parallel lines and you don't want to write the word parallel, say we have line L and say it's parallel to line M, you just draw two really big parallel lines to show, hey, line L is parallel to line M. Perpendicular is a upside down capital T. And the way to remember that perpendicular means 90 degrees is there is I always draw the little square right there when I show that notation. So next to the word perpendicular on your paper, I want you to write that upside down capital T. Draw the little box to show a right angle. I want you to memorize this because it's going to come up again. Okay? Parallel, in my opinion, is really easy because it just reminds me of the two L's right down the middle of the word. Perpendicular is the harder one for people to remember. But just it's an upside down capital T, which is showing you exactly what the lines are doing. And it means that there's a 90-degree angle in between them. So right here, I'm going to write upside down capital T with the little box, and I'm going to show myself 90 in parentheses in case I'm having a rough day and can't remember what the box means. And then, of course, what would be a rhombus without just even one more bougie property? And that would be that the diagonals bisect, yes, each other, but they also bisect opposite angles. All right, now let's go to our picture and let's make some marks based on the new stuff, just the new stuff, because there's no way we could put all the marks there. It'd be busy. To remind us what's the new stuff here. All right, all sides are congruent. That's already marked, right? Diagonals are perpendicular. That is already marked with that little right angle. Question. Let's see if you can get this. If two lines intersect at a right angle, they're called perpendicular. How many right angles are actually there?
4.
Very good. I'm going to ask it again because some of y'all answered faster than I was ready. When two lines intersect at a right angle, how many right angles are actually there? 4. Because of linear pair. Now, I don't want to draw all 4 of them because then it's going to get busy and confusing. But what I'm saying is, in if I said, what's the measure of that angle? You should say 90. Two ways to get there. One, vertical, right? Don't forget vertical angles, they're there. So it's vertical from that right angle, so it's 90. The other way to get there is to know that if I have two lines crossing, and I know one of them is 90, well then by linear pair, this one's 90, this one's 90, and that one's 90. And now you can see why it's confusing, because if you draw all four of them. So you just draw one, but you know that deep down there's actually four right angles there. Okay? So that's a right angle right there. Now here's the new part as well. The diagonals, if they're drawn, they are bisecting the opposite angles. So remember, opposite angles are what? Congruent. Well, if the diagonals are drawn, they're also cut in half. Remember, bisect means cut in half? So like up here, this angle would now be equal to this one. And now remember, it's opposite angles are congruent, so that means over here, that would be equal to that as well. All four of those angles have the same measure. So if I give you any one of them, you should be able to label four of them. Then coming over to the other side, this angle is going to be equal to this one, coming across it, which means this is going to be equal to this. There is a lot going on here. You see it? Now, y'all know me, I also always try to say, look for this extra thing. Question, do we have any isosceles triangles here? No. We don't have any isosceles triangles here. We do have right triangles, so make a note. Look for right triangles, and then make a note, a squared plus b squared equals c squared. Now, because we don't have any isosceles triangles here, that's why that's not an actual property of a rectangle. It's just something that exists within a rectangle. It's not a property that follows through to a rhombus. All right, let's go to our two practice questions. Oh my. Okay. Look at number one. Y'all know the drill. The first three are referring to lengths. The next three are referring to angles. Okay, this is a what? A rhombus. The first thing I would do is go in and I would mark what I know has to be equal, since I know it's a rhombus. And that's all four sides, right? So if this is 27, what's this? 27, what about that? 27, 27. All right, now let's look at what it says to find. It says find XY. Well, that would be one of the top sides, so that's 27. And then it says find WP. Okay, WP is a diagonal right here. What? It is 21. You know the other side of that diagonal. Diagonals bisect each other. So if this is 21 here, then this has to be 21 as well. All right, hold on. So that's 21. So then it says find P to Z. Be careful. P to Z would be here, right? Do you know the other part of that diagonal? No. Okay, but if I found the other part of that diagonal, when the diagonals are drawn, what's created within the shape? Four right triangles. So is this a right triangle right here? All right, Pythagorean theorem. You've got one side's 27, you got one side's 21, we need the other side. Yep. Which one's the hypotenuse, by the way? 27's the hypotenuse. It's always opposite of the right angle. So find your right angle, draw an arrow to the hypotenuse. I'm going to have to put it right here. So we've got 21 squared plus, we don't know, squared equals 27 squared. And this does end up being, I think, fairly ugly, so we're going to just round. Alright, so you'd have to go on your paper, square 21, square 27, write it down. Then subtract the 21 squared, whatever that ends up being, subtract it over. And then square root it, and tell me what you get. You get 288 before, and then square root that, and you get like 17. Because 17 squared is 289, so we're just going to round it. Yeah. So it ends up being 16 point something. We are going to say, what did you say, 16.97? So if I said round that to the nearest tenth, it ends up being 17. So we found the missing diagonal part by using the Pythagorean theorem there. Okay. Now I need to erase the picture so we can talk about the angles, because it's getting crowded. Alright, so going back to it, now looking at the angles. You know this is 51. We also know in the middle is a right angle, and there's actually 4 of them, right? So don't forget that, there's actually 4 there. That 51 can actually be copied to 3 more places. Remember that the diagonals bisect the opposite angles. So if that's 51, then so is this. Come across, so is this, and this. You see that? Alright, let's find the angles it asks for. It says XCW. So XCW, well I already labeled it. It's 51 because of the angle being bisected. So this is 51. XWZ. XWZ. Okay, so that's asking for a corner angle. Do you know another corner angle? Because remember, if you know one, you can find all 4. Do you know an entire corner angle at all? Y'all stay with me.
102.
102? Doesn't matter which one you look at, right? This whole corner angle measures 102. Now look at how it's positioned to the one you're trying to find. Is it opposite or is it consecutive? It's consecutive. It's side by side. Consecutive angles are supplementary. So 180 minus 102 is what? 78 degrees. Now it says to find ZYW. ZYW. I have to change colors. It's getting really crowded. ZYW is right here.
No. This is
You're thinking of an isosceles triangle like in a rectangle. If it was a rectangle, you would be correct. But because we're slanted, we don't have those nice isosceles triangles anymore. We do have enough info to find it though. There's 2 ways to find it. One way is to remember that this is what? 90, and that's a triangle. So 180 minus 90 minus 51 is what? 39? That's one way to get it. A second way to get it is to say, well, coming across, I know that this is 78. So this whole corner has to be 78 as well, but I only want half of it. Half of 78 is 39. So that's another way to get it. Okay. Remember, for this test, I'm not expecting you to memorize these properties. I would never expect you to do that because there's a lot. I am going to give you a cheat sheet with all the properties listed. You just have to know which shape you're looking at and which property to use to set it up based on the picture. Okay? All right, let's go to 6. It says if EFGH is a rhombus, find the measure of angle FGE. FGE is right here. So this is my goal. Multiple ways to approach this. What is the one thing you need to remember that you have in the picture when diagonals are drawn? What's in the middle? Right angles. So right here you have a right angle, which means I have a triangle, a right triangle, and I know this is 5x minus 7. If I could get the expression for this, or the value of this, then I can answer the question, right? All right, so look at it. What? I made 39 degrees? Oh, is that bothering you now? All right, look at what they give me to start with. They give me some polynomial expressions. Y'all stay with me. This one is pointing to this little angle, and this one's pointing to that angle. What's the relationship between those two? They're congruent to each other. Go to your picture up here. Remember the diagonals, if they're drawn, they're cutting the angles in half. That means that this is equal to this. So that's your setup. That's your setup. Solve for x. What'd you get for x?
14.
Did anybody not get 14 and needs to see it?
That's the answer, right?
No.
No, remember the goal was here.
But aren't the sides equal, like all the way around?
No, just look up there at my picture. So if I know x is 14, I can find this angle right here. You all right, Isaac? Itching to get out of here?
Yes. I don't like math.
Plug x in, and what do you get for that angle that's right here? 63. How is that going to help me?
Because 63 plus 90.
And then that third angle that I need, subtract that off 180. What do you end up finding the angle to be? Yep. All right, y'all know the drill.
Oh, yep.
No,
One of these.
Oh,
I'm
God.
trying to give you a break from Delta Math.
Thank you so much.
This is page 37. Nope.
I know how to do it.
Because it goes in your notebook as page 36.
Go for it.
Thank you so much.
then,
Hey, you know what?
What was
the classrooms have a very well says Holcombe. And you just click and sign that.
I told you.
I don't want to hear that, but I've got two big old maps.
And you should already be signed into Google
Oh, yeah,
Slides.
right.
This time. So you already signed in.
That's unlikely.
Fill that out.
Did you get like a change of heart or something?
What are you talking about?
You didn't put it back from this one.
I'll
Instead of me turning on this or something. Oh, I should have said nothing. She didn't know.
I'm about done. Ben, you sold. Ben.
She can't change the thing now.
Oh, do we need to go from back? You're still recording.
Oh yeah, I am recording.
Hey, YouTube.
Okay. This is page 37. Page 37. You will notice there are only 5 questions. Granted, each question has multiple parts, but there are no algebra questions. You're welcome. I think it's challenging enough. Rhombi are like really complicated, so I feel like it's challenging enough to just be able to work with numbers. If you can't work with just the numbers, then the algebra is like, to me, 10 times harder. So you're welcome. They're all just basic numbers. Every single one of them is a rhombus. Some of them are giving you questions that are saying, you know, like what are the side lengths or the diagonal lengths, and then some of them are asking for angle measures, okay? And you're welcome, they're just numbers. Like it says find the measure of angle 1, instead of saying find the measure of angle X, Y, Z, or whatever, okay? Let's refresh your memory up here where it says Rusty's, or as yours is supposed to say, plus D's. I don't know why mine looks weird. But anyways, let's write the 3 properties that were the extra. First off, it was all sides are congruent. All 4 sides are congruent. The second one was diagonals are perpendicular. What does that mean? What angle exists if they're perpendicular? A right angle. I want you to write that. And then the third property was that diagonals bisect opposite angles. And then it would probably help you to copy the exact picture from your flip book that has the marks to right here. Let's just draw a rhombus as best as we can. You're just drawing like a square tilted, right? Try to draw the diagonals. Alright, and then now let's make marks. We've got 4 congruent sides. We have right angle in the middle, which means 4 right angles. And then now let's go in and mark those congruent angles, because that's really going to help you with question 4. Remember, the congruent angles are in opposite corners. Alright, so hopefully that picture helps you to remember how to set this up. Don't forget too, the diagonals do bisect each other, so they are cut in half, okay? Alright, look at this one. JK is 12. JN is 7. That's a right angle. I would draw the right angle every time, so you don't forget you do have a right triangle. You have 4 right triangles in here. Alright, and then it says find JM. JM is one of the 4 sides. So what's JM have to measure?
12.
Yeah. JL would be the entire diagonal where you know part of it is 7. So what's the whole thing? 14. MN would be the other diagonal. We don't know anything about it. Enter Pythagorean theorem. We need to know what this is in order to be able to say what MN is. So you have your right triangle there. Draw your arrow to the hypotenuse, which is going to be 12. So we've got a squared plus 7 squared equals 12 squared. And you can see now why I didn't throw the algebra questions on there, because this, if you've got a Pythagorean theorem problem, it takes more work. All right, 225 is 12 squared, right? No, it's not. 144, I'm thinking of 15. 144 is 12 squared. Subtract 49. What do you get? 95. All right, let's square root that. It's going to be ugly. All right, so we'll just leave it at 9.7. So if this is 9.7 here, 9.7, then what would that be? 9.7. You could round up to 10 if you wanted to.
So you want to know how I solved that? I just added 2 to 7. Like I literally just.
So that's just luck.
Yeah, I skipped it and I was just like.
Yeah, don't do
the other
that.
one's slightly bigger.
Yeah,
so
don't
I
do
just
that.
added 2 points.
Yeah, don't do that.
2 points.
MK would be
Wait,
that
3
whole
points, 3
thing.
points.
So 9.7 plus 9.7 would be 19.4, right? Yeah. No, it's not. We got 5 more minutes, and I just helped you with 1 of your 5 problems.
Thank you so much.
Mm-hmm. All right, I'm gonna let y'all work. I want you to try this.